Now, um, this is a very brief overview of Java language. So, just so you understand what's the examples we can use. The Java language is very versatile. You can use it from, it was originally created to run in Blu-ray devices and the very small devices, but now it runs from your SIM card to phones. There was a Java mobile. At some point there was a Symbian for Nokia. It was based in Java. I mean, it was not developed in Java. All the applications the applications were made in Java. It's object oriented. It's simple. It tries to be as simple as possible, portable, as we say. It can run in many operating systems and hardware architecture, and robust because the Java virtual machine is bytecode that is interpreted by a virtual machine. There's some hardware implementations, but usually is emulated by a virtual machine. It was developed by James Gosling when he was working at Sun Microsystem, and you can see a picture of James Gosling here. Probably not the most flattering, but I couldn't find a non-copyrighted picture. Now Java is owned by Oracle Corporation. There's the Java virtual machine specification is open. Oracle has its own implementation. It's a reference implementation. There's more implementations. There's quite a few Java virtual machine implementation around, but that's beyond the scope of this video. Well, you can just use the, unless you have a very specific need, just to learn and to develop on your own, you can use the Oracle virtual machine. You can use OpenJDK. Anyway, it's one of the most prominent language worldwide. I always say even if no more code, no more new programs, new more code were written in Java, I still will have a secure job for at least the next 20 years because of the amount of code already written in Java that needs to be maintained. So I'll stick to Java, and I haven't been looking at all these new languages because this is a very personal decision. Doesn't mean that you have to do the same, but I can assure you that if you're good with Java, you're gonna have a secure job for the next 20 years. The philosophy is write once, run anywhere. I'm not going to do that joke. As I said, the Java virtual machine is very widespread. You can use it on Linux or Mac, Windows, Solaris, and Intel processor, ARM processor, MIPS. Anyway, it's ideal for building cross-platform, application, web services, and this UI There's Java effects or swing. You can have graphical interface applications that you don't need to build. You just build once and you can then distribute for Windows, Linux, Mac, and anywhere. Now, key features of Java. As I said, is object-oriented. Uses everything is a class. That's a feature of Java. You can use encapsulation, inheritance, polymorphism. It's a single inheritance. You can have multiple inheritance. That's decision. That's a design decision. You can have interfaces which define behavior but not implementation. That's object-oriented. You have the platform independence. As I said before, the programs are compiled into bytecode and then they are run into Java virtual machine. This virtual machine, there's different implementations and you don't need to know the specifics, but I can tell you that the modern virtual machine are as fast, and some scenarios are faster than native code because of so many there's so many optimizations they add to the implemented code. Yeah, you can use the same code for desktop, well, mobile, and embedded up to some extent. It's got memory management. The Java virtual machine implements garbage collection. You don't need to release you don't need to manually release objects. Of course, objects related to memory. Of course, you need to deallocate other resources like files, sockets, everything's a file. Open file of any type, because the virtual machine cannot do that for you. You can still have memory leaks. I've seen a few. I had to fix quite a few. In the automated garbage collection does not. I mean, it means you won't have a memory leak. You will, but it's usually a bug on your side. Sometimes it's a bug in the library you're using, but usually it's on your own code. But yeah, you don't have to be that concerned with releasing memory, but you still need to be vigilant. And as I say, it's got a rich standard library. In the Java runtime environment, provides quite a few functionalities with like most of the data structure we're gonna see here. Network, like sockets and other high-level network operations, I/O operations, file, multi-threading, and graphic user interface, widgets. They are already implemented, so you can focus on your program's task and not to reinvent the wheel every time. That's why. Okay, well, now we have a very, very bare bones Java program here. You can see the package name that's equivalent to some other in other languages. Namespace is basically where the class lives inside the project. There's some conventions, but basically the package can be anything. But again, there's some conventions, as you can say. It says in line 1 com Java Druid. Usually it's the reverse fully qualified name, and then the project name. In this case, it's just maybe project 1, just a very generic name. Inside this package, you can have more packages. You can organize your Java program so you can find and organize the different functionalities, but we go deeper in that in a further program. Now in line 3 you can see the class name is a public class, which means that anyone in this JVM can use it. Can see this class defined is a class. Hello world is the name of the class, and as you can see, this is a C style with curly brackets, and you can now we define there's a lot of argument whether you put the opening bracket in the same line. Most Java source codes are seen just like that, or you can have it in the next line. That's more like .NET style. I'm not going to get into the argument. Just let you know, by default, most IDs and most of the source code I've seen and I work with is use this style. Okay, so now use this and then we can argue. Now we define this function, which again is public in line 5. Again, is public. It's a static function, which means it can be seen from, it is not linked to a specific instance of this class, but is linked to the class. We'll see in further videos, probably in the different series, we're gonna see what that means. But for now, you just need to know the static means it belongs to the class, not to the instance. It's a void. This is the return type void, because it doesn't, again, like in C, this a lot of is borrowed from C. A lot of the syntax is borrowed from C. It's a void, which means it doesn't have a return type. It doesn't return anything, actually. You cannot return anything. And now this is the main, this is the function name. I mean, I will use function method. There's all methods are functions, but the method did not return, except in the function does have a return type. I will use function interchangeable with method, but just so you know, when I say method, it is a function that doesn't have a return. Just that. It is called main, and between parentheses you have the arguments. In this case, it's an array of strings called args. This specific main function is just very similar to to see if you know some. See, you're gonna find very many similarities in the syntax. This is the first. This is where your Java program starts. You can have many. In that case, you're gonna have to specify which one you want to run, either by command line or in the manifest, but that's a separate discussion. Just so you know that the main function is where the program starts, and this is where you when your code starts. Now, just small parenthesis and continue. Now, in many enterprise environments, especially when you use some framework like Java Enterprise or Spring Boot, or the Spring family, it's very common that these frameworks already include a main, and so you don't have to implement it directly. You just need to specify and declare. Sometimes you do need a main. It depends on which framework. Another exception is, as I mentioned, Java Enterprise Edition, because you're not gonna run from a command line like a separate process. You're supposed to run inside an application container like Tomcat, Glassfish, Tommy, and Jetty. There's a lot of them, but for now, you're gonna have this main function, and this is where your program starts. From here, you can call all the rest of the functions. This is the simplest application. You just printing this text hello world, and that's it. This program doesn't do that. This is just for you to see what the simplest Java program looks like. If you compile, you run it, it will print to the console, to the terminal, and it will finish. That's it. I just want you to have a very basic knowledge of what Java looks like. We can go deep into Java, as deep as you want. Let me know in the comment. In different series. Okay. Now, this is an interface. It's called, as you can see, you already can see the package name. In this case, it's the same as the main, because we have a very simple program. In lines 3 to 7, you have some documentation. It's called JavaDoc, where you can add documentation to every interface, functions, variables, constants. Again, comment. I'm not going to get deep into comments. Just so you know, you should comment interfaces, especially the things you should cover what other people will use. So anything that's exposed, like in the library, every interface, every implementation, you should document how to use it. In the code, this is a different documentation. Now I'm talking about the JavaDoc. You can see it's a comment, like it's a multi-column comment. The only difference for JavaDoc, you can generate HTML documentation from this. It's got 2 asterisks instead of one in a regular comment block. You have only one asterisk. In this case, if you start with the two asterisks, the IDE, some other processors will recognize Javadoc and will use this content in many places when you're looking at the code, where you can generate HTML documentation, as I said before. Here you can just explain why is this interface useful. You can add some tags like the author or other, if it's deprecated, since which version of your library is being used. There's a lot, quite a few. Just so you know, you can do that, and this is useful because other people will see it and will read it. I'm not gonna get into what is a good documentation, separate series. So let's move on. In line 8, you can see this is a public interface which is accessible by everyone else in a separate video. We're going to get to the access scope. So you know, you have public, everyone can see it, private, only inside the class, and you have protected, then only the classes that inherit, and those in the same package, and the default, which only in the same package can see it. I'll get into that in a separate series. Now, interface. The interface here means, because you saw in the previous class it was a class. Now this is an interface. The interface defines which functions a class can have. Then you're gonna need a specific, more concrete implementation of this interface, and you need to implement all of this method unless you're using an abstract class that's for more complex, and you can, and the interface defines the what, not the how, except after Java 8 you can have default implementations in your interface. That's useful, but needs to be used wisely. But don't get to an interface defines functions, and you can also have static variables like constant, but we're gonna see that separate again. You see here it says no implementations, and there's an asterisk after Java 8. You can have some with some restriction. You can implement some functions here, but again, separate series. Now this is a more complex class. This is this is a very simple example. As again, this is a class that implements interface card, the interface we saw in the previous slide. Again, in the same package. You don't have to. It doesn't have to be. Can be in any package. Now you have here 3 internal variables. These are private variables, or members, variables, members, instance variable. You can see with those different names. Now it's final. These variables are final, which means that they can only set once. Actually, they have to be set at the time of initializing, either here in line or with the constructor. We're gonna see what is the constructor. It's a special function that you can use to create a new instance of this class. We're gonna see how we do that. Now this constructor receives these 3 variables. You initialize here. This is a very simple constructor. You could have more complex behavior in the constructor depending on what you need. You may want to, in this case, this specific class is purely a data class that we could have used a record, but that's if you're using Java 11 or more recent. And again, separate series. For now, let's stick to more traditional Java. So here you can see brand, model, year, and drive. These are the functions defined in the interface. You see implemented here. As you can see, this function don't have any body. Here they do have a body. You have curly braces here, and well, the only code is to return the value of, return the reference to the instance variable here. Do you know a variable? How do you know a function is an implementation of a function from an interface? Because of the signature. The signature is the return type and the parameters type. Now, with that, the compiler knows that this is an implementation of the function declared in this interface. Now, optionally, you can add, which is advisable, you can add this annotation as override. This is not mandatory. You can add in a lot of code without this, and it compiles with no problem. This is just for us, for the programmers to know that these functions either implement or override a function from a parent class or an interface. Yes, and as you see, it just returns, and the drive just prints some on the screen. This is a very simple one. Okay, now how do we put all this together? Okay. Now we have a separate main class, which is called demo. Now you see this main function in lines 5 to 8. This main function does a bit more than just printing hello world. It creates, you declare a variable of interface car, and you create a new instance of a specific of a concrete implementation, and you declare it final. Final means that once you initialize it here, you cannot change the reference of this variable. Basically, if you declare a final variable means that you cannot change the value and so basically you cannot assign. Again, this is all. This is for a Java series. This series is for just for data structure and algorithm. I just want you to know the basics of Java. When you see final, you know that you cannot assign to anything else. A final, you have to assign on when you declare or in a constructor. Period. You can the compiler won't let you if you declare final my car here and then you try to initialize in the several line, the compiler will give you an error. And now, as you can see, I can assign a internal combustion object to the variable declared as interface car, because internal combustion is a car. If you know how polymorphism works, that's what's happening here. And then you can execute, you can run this method on the interface, and then because this class implements this interface, you can run it, you can drive basically. Okay, so that's most of it. Well, that's what you need to know about Java. I'll be showing you as we go what you need to know, but I just want you to understand, at least you can read some Java code, right? Yeah. Okay. We're getting to the end of this video. What we in this series, we're going to leverage Java's object-oriented features and some functional, which I didn't mention earlier, but starting from Java 8, there's functional features you can use in Java, but that's we're gonna see that in the separate series, and in this one we're gonna see just what we need to understand. We're going to explore the range of data structures, like arrays, linked lists, tags, queues, trees, graph, and some of the algorithm that we can use with them. Remember, data structures and algorithm, they're related, because one is about how to store data in memory, and the other one is how to use that data to get the result. They result like sorting a list, an array, searching an element through a list or a set or any collection in general, traverse, a graph, a tree, and many more, and how we're gonna see how they can be implemented in real world scenarios with Java. We also gonna look at some implementations in the JDK, and probably take a look at why it's more complex than you would think, and why sometimes you need to. Why, unless you have a very specific need, you don't have to implement all those data structures and algorithm, unless that is you have a very specific need, which I never found in over a decade in enterprise, I haven't had to implement a list or a tree or a set. I've had, however, and this is why you need to know this. This all this basic data structure. Let me go on a tangent here, but almost all data structures and algorithm the you're going to study here, they are already implemented. You're not supposed. I mean, you have to implement if you're studying. You need to implement and know. But in work, at least in enterprise backend, well, that's what I've been doing. That's already done. You your employer doesn't want you to implement an array list or a linked list. Not usually. But you need to know how all of this works, because what your employer wants is to have a correct code. Your employer doesn't, and your employer doesn't want you to implement a linked list from scratch. Your employer wants you to solve a problem, and you're gonna need to understand how any of this work and which algorithm is best for this scenario you have. What your employer care about is how much it would cost, how much memory, how long it would take to get an answer. And that's why you need to know all this. And focusing on Java, you need to know how Java works. Okay, off tangent. Yeah, we're going to see all the algorithms with implemented in Java, and we're going to analyze and different ways to implement, because not all implementations are equal, and some are good in some scenarios, some are best in different scenarios. Now, for it's the time for question. Just pause the video here and try to answer for you this question. These are not, for now, these are not very difficult questions. Just try to answer without looking back to see if you can respond, and how much you can respond from memory. Yeah, that's gonna leave you for some time. Just pause and read the question. And that's it for now. This is the first video. If you like it, you like the video, like it, subscribe if you are interested in this kind of content. This is the first series. I'm planning to do a lot more series. Let me know if there's a specific topic you want me to cover. Yeah, because I have some ideas. You could have some better ideas. And if you know if anyone is interested in it, share it and send it to some, especially young people that are starting to go to college, or even if they're not studying, you can learn a lot. Okay, so cheers.